Hey, Algebra 2, just want to take a look at another type of problem that seems to be giving us some trouble. Yeah, let's take a look at it. So least common, whoa, that's not the right question. We can do that one as well, but least common multiples. This is an important thing to be able to do with whenever you're adding or subtracting fractions. So let me take you back, way back when. If I want to add something like 4/5 plus 9/8. All right, if I want to add those fractions, we had to do a thing where like we can't add those because they don't have the same denominator. So we had to get them to a common denominator. And so we would do a least common multiple. And sometimes the least common multiple would just be you can multiply those two numbers, right? 5 times 8 is 40. And in this case, that is the least common multiple between those, right? There's not any other multiplier we could get to. But there are other situations where you don't just have to multiply. So like once I realize I can get those both to 40, right? I could realize, oh well, then I can multiply this one times the bottom times 8, tops times 8, and the top and bottom times 5, and ultimately that would get me to 32/40ths, right? So that's the same thing as 4/5, and 9/8 is 45/40ths. And then I could go ahead and add those two numbers, and I'd say, oh yeah, this is what is that? 77/40ths. All right, so that's what 4/5 and 9/8 adds to be. But in other instances, there might be some other common multiple that you can have between numbers. So if I have like 3, let's try and come up with a number that wouldn't reduce, 3/4 and 5/6. So these can both go to, we can multiply those and get those both over 24, 6 times 4. I could just multiply those. And that's a multiple of both of those. I can multiply this one by 6, and I can multiply that one by 4 to get to that, multiply the top and bottom by that. But we can do it smaller than that, right? In this case, our number that we can actually do those both to is 12. 12 is the least common multiple of those two numbers. And so you might just know that. We can also figure that out through factoring. So this 4 does factor into a 2 times 2, and this is 2 times 3. So I've actually already got like a 2 factor in both of those. So kind of what's missing over here is I need a times 3 more, and then what's missing over here is another 2. But I already had like the 2 factor in both of those. So that's kind of what we're going to be looking for here. I can get both of these, like I said, to 2 times 2, so 4 times 3 is 12. I can get both of those to 12 by here. All I need to do is multiply by 3, and I'm going to do it on top and bottom. And then here I'm going to get to 12 by multiplying by 2 on top and bottom. And so this fraction ultimately becomes 9/12 plus 10/12. And now I can go ahead and add that and get that that's 19/12, right? And then that won't reduce. But if I had done this multiplying by, and that should, or it should already be reduced, right? There's no more reduction we can do. But if I had done it multiplying by 6 on this side and 4 over there, I would have ended up with twice as much of that, because I would have had an additional factor in there that was unnecessary. So that's the idea of a least common multiple. Now we're going to try and do it with these big old ugly things. So imagine these are denominators in two fractions. I need to get them the same by multiplying by something, but I don't want to just multiply those together because that would be a massive beast, those two multiplied together. So what we got to do here is factor them, find the common factors. Those we need to make sure we have like all the same factors on each side. So we're going to factor these completely. So on the left side, I can factor out a 5, and I can factor out m to the 5th. All right, so I've got 5 as like my coefficient, m to the 5th. That's how many m's I can factor out of here. And so once I divide away that 5m to the 5th, that's going to leave me with m squared. Divide away my 5 there, I have 7. Divide away my m to the 5th, that leaves me with just an m. M to the 6th divided by m to the 5th is just m. And then 50 divided by 5 leaves me 10, and then no m's. All right, so I'm going to turn that into a parenthesis. And so that's we've factored out a greatest common factor there. Then can this factor further? Can we do, we have a quadratic. Can we factor that further? Yes, we can. So m plus 2, m plus 5. Those two will multiply to be 10, add to be 7. So if I FOIL that together, we got this. And so now this left side, this is fully factored. Do the same on the right. What can we factor out of here? I like to make my leading coefficients positive when at all possible. So I'm going to actually factor out the negative as well as the 20, and because all those are divisible by 20. So I'm going to factor out a negative 20, and then we've got m to the third we can take out of everything. So m to the third, we can divide that away. And so that's going to leave behind. We divide by negative 20. It's positive now. M to the fifth over m to the third is m squared. Negative 80 divided by negative 20 is positive 4m. And then 100 divided by negative 20 actually was positive. We'll go to negative now. And so that will be negative 5. So then, can I factor that a little further? Yes, we can. So this is m plus 5 and then m minus 1. Because 5 times negative 1 multiplies to be negative 5, and then those will add once we FOIL together. Outside, inside adds to be that 4m. And so this ultimately is what this looks like in factored form. So you'll notice we've got m to the fifth and m to the fifth already covered. I don't need to multiply by an n by the fifth. I already got that in both of those. All right. So we could break this down a little further. We could think of this negative 20 as 5 times negative 4, right? So ultimately I've got a 5 in both of those, but I need a negative 4 over here. So we're going to multiply this left side by negative 4 to ultimately get to where they're both the same. So that's what we would kind of be doing in our in this. We need to multiply by negative 4 over here. So, I can even kind of write that in if you want to work it this way, times negative 4. That'll get that to where we're negative 20 on both sides. So the left side needs to be multiplied by negative 4 to get that factor in there. The right side, notice I got m to the fifth here and m cubed. We could write this as m cubed times m squared. So I need to get my m squared over here. All right, so that we could multiply by that over here. So ultimately we had kind of added that times negative 4, added to this side. The m to the fifth was already covered. Over here, we can multiply by m squared. So this ultimately is m cubed times m squared. And I would multiply the numerator and denominator if I were doing this, but just kind of get these to the least common multiple. And then the last thing we have is I'm missing the m plus 2 over on this side. So I'll multiply by an m plus 2 on that side. And then I'll multiply by the m minus 1 on this side. All right, and so ultimately what I had to multiply on the left side, I had to multiply by that negative 4 and that m minus 1. That's what we would have multiplied the numerator and denominator by over here to get that that 5 to a negative 20, and then to kind of have these 3 binomial factors. The m plus 5 we didn't have to do. That was on both sides already. The 5 was already on both sides. So I had to multiply by the negative 4 over here. And then what I had to multiply by on this side was the m squared and the m plus 2. Those were kind of the 2 additional factors here. But at this point, I didn't kind of write it all out. I can kind of write it this way. Negative 4 times negative 5 m cubed times m squared. This is a little bit spread out here. M plus 5, m minus 1, m plus 2. This would be the same as if I did the same thing over here. I could write that all out. Both of them would be the same. So now we can multiply this back together to make it a little bit more presentable. So I would probably leave this as negative 20 m to the fifth times that m plus 5, m minus 1, m plus 2. And that's where I would get both of those denominators to.